Welcome to Cow Talks. This is Marcelo Wallau, Forage Extension Specialist with the University of Florida. And this is our podcast, where we dive into the main topics affecting livestock and forage production in the southeastern United States. Join us in this journey as we tackle the main issues affecting our producers and the sustainability of our production systems. Hello and welcome to Cow Talks. This is Marcelo Wallau, Forage Extension Specialist and Associate Program Leader for the University of Florida. And today is our inaugural series of our Researching Perspective. This is our effort to bring you the latest in research and show you what is coming out of our research stations that can help farmers in the southeastern United States. Today my guest is Dr. Hannah Rush. She's an agronomist agroecologist with the University of Minnesota, focusing on sustainable cropping. And she got her PhD from our ranks in the agronomy department at the University of Florida a few years back. I had the pleasure to work with Hannah in multiple of her projects, and she's here today to tell us a little bit about two of her latest research, one involving establishment and also the second one in terms of diversity. Hannah, welcome to Cow Talks.
Thank you very much. It's a pleasure to be here.
So we're getting close to the planting season now as we're recording this podcast, and people are getting ready to plant their cool season forages. One of your research trials was, and that we're getting close to publish hopefully soon, is related to establishment strategies for cool season forages in Florida. Can you tell us a little bit more about this research?
So the study that we were working on was looking at 3 different establishment methods using conventional tillage, no tillage with an herbicide desiccated sod, and a no-till sod. And this was into Bahia grass. And so we were looking at these 3 different establishment methods, and we also wanted to look at how the interaction of nitrogen fertilization specifically would perform. So we looked at a zero nitrogen control, and we looked at a single application of 80 pounds of nitrogen per acre at planting, and 2 different split applications, one where we applied 30 pounds of nitrogen at planting, followed by 50 pounds of nitrogen per acre 45 days later. And then the last treatment, we just did the split the other way around. So we applied 50 pounds of nitrogen at planting, followed by 30 pounds of nitrogen 45 days after planting. That was the way that we set up the experiment, and our goal was to understand what were the effects of these treatments, where we have the combination of the establishment method in terms of the land preparation and the timing of the nitrogen fertilizer for those cool season crops that are getting established. We wanted to know what the effects were on soil moisture, particularly because the conservation tillage methods might help to retain some soil moisture at a time where we have limited precipitation in Florida. And then the nitrogen fertilizer strategy was to try to time delivery of the nitrogen fertilizer when the plants needed to take it up. So the idea being with the split applications that some fertilizer would be needed at germination for those young seedlings to take up, but more of the nitrogen would be taken up by plants that are a bit larger and able to take up more nitrogen with a larger root system. So those were kind of our objectives, to study the soil moisture, how the nitrogen timing impacted tillering of those grasses when they got established, and then also looking at the forage accumulation. And I should say we also included legumes in the study. However, we found that these were pretty marginal in the end, and so we didn't end up discussing them in the paper that we're hopefully going to have released soon.
Yeah, so kind of decomposing a little bit of your treatment. So we're first looking into the different planting strategies. We either go in no-till or prepared seed bed. We know when you have prepared seed bed, you eliminate a lot of the competition. What would be the advantage of that no-till?
So the idea with the no tillage was primarily as like a water conservation strategy. So you're right. If we have a clean seed bed to plant into, then that's going to get rid of some of the competition with the Bahia grass, which is a really vigorous perennial grass, of course. And it starts becoming more dormant at this time of year. If we do conventional tillage, then that is going to affect our next year, our subsequent years, Bahia grass pasture, of course. So if we no-till, there's a chance that that Bahia grass pasture will still be productive the next season. And the thatch from that grass can help to protect the soil from evaporation of water that there is in the soil to try and keep that water there for the seeds to germinate and become established. So that's one of the advantages of the no-till. But like you say, there is some potential for competition, especially if the Bahia grass hasn't gone dormant already. And that's why we also used the treatment where we applied glyphosate to kind of simulate a early dormancy of the Bahia grass to try to bring down the competition for Bahia grass, but keep the effect of holding in moisture to create an environment favorable to the germinating seeds.
Just to clarify, that herbicide we applied at glyphosate was just a small rate of glyphosate, not a full rate, correct?
That's correct. Yeah, we didn't want to kill the Bahia grass with the glyphosate. We just wanted to desiccate the growth above ground so that it would essentially give the seedlings a chance to get started.
Perfect. What did we see in terms of water? So one of your ideas is that the no-till will help conserving water because it was not exposing that soil to air and to sunlight, not breaking down the soil structure, and that would conserve water. What did you see that in terms of water?
We did see what we expected to see in terms of a lower amount of soil moisture under the conservation tillage compared with the two treatments where we had no-till and the no-till with the herbicide. So we did see that, especially when there was no nitrogen applied or a single application of 80 pounds of nitrogen applied at planting. When we looked at the treatments where we did the split application, there was a smaller difference between the conservation tillage and the two treatments where we did not apply tillage. And this is probably a result of greater biomass actually produced in the split nitrogen applications because as the plants are growing, they're also drawing up the water from the soil and using that, and it's being transpired through the plant instead of evaporated from the soil in the case of the conservation tillage. But there is still water use.
So that conservation tillage helped us maintaining and get those plants going and preserving and retain soil moisture whenever we had some rain. So looking into the nitrogen fertilization rate, the idea here was that many farmers are applying just once. They don't want to split application because you need to come back into the field again. And applying once was okay, but not the best. What did we see in terms of split applications and the relationship to the land prep method?
Yes, when we did the split applications, we saw that the best result in terms of forage accumulation was when we applied the 30 pounds at planting, followed by 50 pounds 45 days later of nitrogen. And so that gave us the highest overall forage yield. And that was followed by the other split application where we applied the 50 pounds of nitrogen at planting, followed by 30 pounds of nitrogen 45 days later. So we did get a boost in forage accumulation when we had, in particular, the no-till land preparation with the herbicide, the glyphosate, plus the 30 pounds followed by 50 pounds. That produced the highest amount of forage accumulation in our experiment. And the no-till without the glyphosate, so just the no-till, didn't produce quite as much as when we did use the herbicide to control some of the competition from the Bahia grass.
Yeah, that was very interesting and pretty much confirmed the hypothesis we had that we need to match that nitrogen supply with the demand we have from the plants. But also we don't have only from the cool season forages that we're establishing. We also have some demand from that Bahia grass that is active. When you have it competing, it's going to be active. It's going to take some of that nitrogen. It was very interesting. Very interesting result. What would be the recommendation for our farmers here to get the most out of their cool season forages?
So, based on what we saw, folks are able to use a no-till drill and they can burn down some of the Bahia grass before planting. And then, if they're able to no-till drill their seed, grasses in particular, and I didn't mention this, but we planted a mix of grasses that included cereal rye, oats, and annual ryegrass. Those are the grasses that we used in our mixture. And then if you are going to do the split application, then applying the 30 pounds at planting of nitrogen, followed by the 50 pounds. of nitrogen 45 days later, then that will hopefully give you the best result, just like what we saw in our study down in Citra.
Fantastic. And just to put some parameters here, we're talking about early season fertilization. Of course, if we want that forage, that pasture to continue producing throughout the season, we may need to come back mid-season with another application after some of the grazing events. But that initial phase is essential for us to get a good start, because those cool season annual forages are extremely responsive to nitrogen. And when we fail to deliver that nitrogen early on, they are not just late in coming up, but also lower productivity compared to when you come early on and supply that nitrogen when plants need right at tillering. Awesome. So you mentioned a little bit of mixes. You mentioned the use of rye and oat and ryegrass and other things and clovers before. I want to plug this with another paper we got published, which is another chapter of our PhD dissertation, which is related to species diversity and also functional group diversity. Can you tell us a little bit more about that trial?
Yeah, that was a trial that we conducted in Gainesville and in Mariana. So we had two locations for this one. And we looked at combinations of grasses on their own, either one, two, or three species of grasses. And then we looked at mixtures of grasses and legumes. So then we increased it to one legume and one grass, or two legumes, two grasses, three legumes, three grasses. So increasing both functional diversity there by incorporating a legume that can fix nitrogen from the atmosphere and make nitrogen available in our system, and the grass, which is a really good scavenger and good at putting on biomass quickly. We did an additional functional group with brassicas. So we were using things like rape and kale and radish. So we had up to 9 species in a mixture, and that would have been 3 grasses, 3 legumes, and 3 brassicas in that case. So we had a range from one grass all the way up to that 9 species mixtures that included a single functional group with that one grass, up to 3 different functional groups having the grass, the legume, and then brassicas, which are also quite good at taking up nitrogen and putting biomass on very quickly.
So did we see there in terms of response? Is a nine-way mix necessarily better than a simpler mix?
So the things that we were interested in evaluating were things like the forage of accumulation, of course. And then we were also interested in the case of the legumes about how much nitrogen they are introducing into the system. So to get back to your question, in terms of a forage accumulation, do we need 9 species? Yes or no? And I would say it depends, and that's often the response. But we saw two different things. So I'll mention two things. One, we had a different performance depending on the variation. So in Gainesville, where we have more coarse soils and less rainfall compared with up in Mariana and the Panhandle, where they get a little bit more precipitation during the cool season and the soils are a bit heavier, we saw greater forage production overall up in Mariana compared with Gainesville. But in both cases, we did see an increase from 1 to 2 to 3 species of grass, for example. So if you're going to plant just a grass, then there is some benefit from planting at least 2 and even 3 grasses. If you're going to add legumes, there was also a linear increase. So each time you added a grass and a legume from 2 to 4 to 6 species, especially at Gainesville, we did see increase in forage accumulation both years. So that was great. In Mariana, however, we saw pretty flat if you added additional legumes. So that was a really interesting finding, especially because Mariana produced more legumes overall than Gainesville. So that kind of leads us to believe that perhaps the grasses in those grass legume mixtures were really what was driving the increase in Gainesville. Whereas at Mariana, there was maybe more of like a equal parts, and so that's why it looked a little bit more flat. Overall, though, the greatest production that we saw in Mariana were in the treatments that included all 3 functional groups. Not necessarily 9 species, though. Having 6 species or even 3, where we had one grass, one legume, and brassica, produced similar amounts to 3 grasses, for example, in the first year at Mariana. And in the second year at Mariana, having 2 grasses, 2 legumes, and 2 brassicas. increased the amount of biomass compared to other treatments. So 9 species, I would say, is not necessary to maximize the forage accumulation. However, including up to 6 species did seem to have a significant impact in both years. And those 6 species could be 3 grasses and 3 legumes, or 2 grasses, 2 legumes, and 2 grasses.
This is a topic that often get asked about. What mixes should I use? How to blend those forages? And I am very fond of telling we don't need a lot. We just need targeted effort here. Species that complement each other in time, in space, in functionality, and in resilience. We cover those, we're good. We don't need to add a lot. And I think this trial really helps us showing that diversity is extremely important. Excessive diversity is not necessarily better. At some point, it just becomes, from my opinion, an expenditure in seeds or a waste of seeds. But that was very interesting. The other thing that you measure was related to nitrogen fixation. In one side, you had an important contribution of the legumes towards the nitrogen in the system, right?
Right, yeah, particularly at Mariana.
Yes, and I was very, very interesting. There's also something that people get confused is that legumes fix nitrogen, it's going to be directly available to grasses, and that's not really true, right?
No, there is a time lag because the legumes, they'll fix nitrogen from the atmosphere with this relationship that they have with soil bacteria called rhizobia. And those bacteria live in the roots of the legume in little nodules that they make on the roots. And so the nitrogen is immediately available to the plant, but before the nitrogen becomes available to the soil for other species to take up, like the neighboring grasses, for example, then that tissue that the legume has with the nitrogen in it needs to break down and decay. So that could be the roots themselves that are breaking down and decaying, or the above ground leaves and stems that's breaking down and decaying. So that's going to take some time for that decomposition process to take place and release the nutrients, the nitrogen in this case, and make that available for uptake by the grasses. So there is a lag.
And for those listeners that are more interested in this specific topic about legumes, we have an episode that we recycled from our sister podcast, Forage Nexus, a few weeks ago into the Cow Talks podcast. And we had Dr. Jim Muir and Dr. Jamie Foster, both from Texas A&M, talking about use of legumes in pasture systems. It was very good, and reinforces that idea that legumes add to the system, not directly to the grasses immediately, and the importance of having those legumes there. Hannah, I think both of those research are very fantastic and very applied to, we found some very interesting mechanistic effects, but also very direct strategies for our farmers to use. Anything else you'd like to share with our audience about your work, your previous work, that you'd include in your recommendations when talking to producers?
Well, this is maybe not for a cool season grass, but I'm really interested in the work that's being done too with the rhizoma peanut as a warm season perennial grass with Bahia grass. So that's another space if folks maybe are less interested in incorporating a cool season annual forage into their systems, then perhaps thinking about incorporating a warm season perennial legume into a warm season system could be another space to explore.
Fantastic. And we'll talk more about the use of perennial peanut in this series of episodes on our researching perspective, because we have some very cool stuff going on about perennial peanut.
Yeah, absolutely.
Thanks so much for joining Cow Talks podcast today and sharing a little bit of your experience in your research, so we get them outside of our research papers and into our farming community here. Thanks a lot.
My pleasure. Thanks again for the invitation. Take care.
This podcast was brought to you by the University of Florida Forage team with technical support from the University of Florida College of Agriculture and Life Sciences, Faculty Instructional Resource and Support Team. This episode was produced by Marcelo Wallau, Olivia Mowley, and Ashley Kanabrowski. We hope you have enjoyed this podcast. If you have any comments or thoughts to share with us, please reach out to us through our email, forages@ifas.ufl.edu, and find us on our social media, uf.forages on Instagram, UF Forage team on Facebook or UF IFAS Forages on YouTube. We hope to see you in our next episode.